In this video, we'll talk about counterexamples, their structure, and how to write them. So before we talk about counterexamples, we have to talk about conditional statements. So conditional statements are what the vast majority of statements in mathematics are written like, and they have a pretty basic format to start with, and there are some complications, but at their core, basically there's if something happens, then I can say something else. Now this if part is what they call in mathematics the hypothesis of the statement. And that kind of sets the conditions. So we see it a lot in theorems. So if you think about the Pythagorean theorem, the if part of that theorem is if I have a right triangle with legs A and B and a hypotenuse C. And it's a very big hypothesis, but we have to have all those things set in place. And then the conclusion of that statement, which would be the then part, would be your classic a squared plus b squared equals c squared for the Pythagorean theorem. So this kind of gives you an idea of what structure most sentences have in mathematics, especially theorems, and this gives us something to actually work with. So for shorthand, usually we have hypothesis implies conclusion. That's what this little arrow means. So if H, then C. And in this case, H and C are phrases. So if I have a triangle with side lengths A, B, and C, and it's a right triangle, then a squared plus b squared equals c squared. So now let's talk about a counterexample. So in a standard H implies C format of a conditional statement, for a counterexample, we have to show we meet the hypothesis and we don't get the conclusion. So if we think back to the Pythagorean theorem, if I wanted to disprove the Pythagorean theorem, all I'd have to do is find one right triangle with side lengths A and B and hypotenuse C that didn't satisfy a squared plus b squared equals c squared. So I'd have my hypothesis, I'd have the right triangle, I'd have the right side lengths, but I wouldn't get to the conclusion. Now we know that it's true, so we can't find a counterexample for it. But this is our general structure of how to write a counterexample. We meet the hypothesis, and we fail to get the conclusion. And for a lot of generalizations in mathematics, sometimes you only have to disprove one case. One case will disprove it all. Unless we're just using a statement where usually they start with there exists, or we're just saying there is one. There's a slight difference there, but for the most part, we talk about generalizations in mathematics. So let's take a look at an example. If A and B are odd, then A plus B is odd. So the first thing that'll be kind of useful to do is to identify our hypothesis. So if A and B are odd, that's my hypothesis. And this is useful because I don't really want to talk about, okay, what if A was 2? Then I don't really care. I'm not really in my situation here. We're saying, okay, A and B are both odd. So A could be 3, B could be 5, great. And the conclusion would be then A plus B is odd. So I'm taking A and B, I'm adding them together, and I want to see if I get an odd number. And I'm not sure if this is true or not. So one thing I'm going to do is I'm going to just look at a potential case. Let's say A is 3 and B is, say, 7. Well, then A plus B is 10. Now I'm looking at that and I'm thinking, hey, that's not odd. That's even. Therefore, it's not true. So, for a counterexample, the way to write this, I would say, let A be 3 and B be 7. Then I can say A and B are odd. I've met the hypothesis. That's what I'm saying here. With all this, I'm satisfying the hypothesis. I'm showing, okay, I have 2 odd numbers. And then I can say, but A plus B is 10. And 10 is not odd. which means this part, I don't get my conclusion. I reach not C. Now in mathematics, it's kind of weird, but an and can be used almost interchangeably. So I can show that I've met the hypothesis and I have not reached the conclusion. And this would be how I would disprove this statement. Because this is a generalization, it's talking for all odd numbers this happens, and all I have to do is find one case where it doesn't. And in this case, I found one. So there's proper format for a counterexample. It helps to identify your hypothesis and conclusion, and then just kind of follow it through. Talk about how you met the hypothesis, but you didn't reach the conclusion.